Welcome to Groundwork, a podcast from McClanahan Corporation to talk about key material processing topics. Whether we're talking about raw material or giving valuable resources a new life, we'll break down the best methods, tools and innovations in aggregate and mineral processing that keep the world running. Because if it's not grown, it's mined. My name is Luka Vasev. I've been with McClanahan Corporation almost 4 years at this point. My background is I worked for a bit more in the screening area prior to this. Richard, would you like to introduce yourself?
Sure. My name's Richard Williams. I've been with McClanahan coming up 12 years, but last count maybe 30 plus years in the industry. Probably my specialisation has been a little bit more in the tailings water recovery area, but we like to keep ourselves versatile and cover the full range of the process.
Absolutely. And the podcast topic that we're exploring today is iron ore processing and challenges and solutions. Richard, what comes to your mind when we're talking about iron ore?
Well, iron ore is a really important export commodity for Australia. I think the largest exporter in the world. So it's a big influence for us here down in Australia. And, the industry has evolved really over the last, maybe 20 years. Prior to that, in Australia, it was a kind of crush and ship operation, mostly, where the ore was good grade, 60, 65%. The Australian miners had a fantastic business exporting, initially to Japan. I think China has taken over as the big market now. But, Luca, you're probably up with this as well. I think the biggest challenge for them is the fact that they've mined out all the good ore. So, as they're having to, go wider, they have to increase the beneficiation and come up with new and better techniques for maintaining the quality.
Absolutely. I always think of this as if they haven't gotten through their iron ore body, the higher grade, there's certainly no new mines coming up, at least in these areas. So the new mines need to think about the wet processing side of things, especially if they want it to start to sit closer to that 60, 62% mark, which we always track as our spot price. So I guess, where do our products, what's the first thing that we think about? I think it's fair to say scrubbers fit into this upgrade process. In some cases, it's the addition of scrubbers to existing operations, and in some cases, it's been new mines being established with those scrubbers. I think we've had both scenarios, haven't we, Richard?
Yeah, certainly in the last, what do they call it, the last Australian boom they talked about 10 years ago. There were, probably a dozen or more wet processing plants installed in iron ore. And, they were supplementary to the crush and ship. Now, when you're talking about the crush and ship, they're normally using, historically, they probably use a gyratory crusher, which has got lots of good advantages for high tonnage hard ores. The hematite that we're familiar with is perhaps a little softer. So there's been a kind of a trend to use a mineral sizer to crush that, because, of course, you have lower headspace, lower infrastructure costs and higher throughputs. So I think that debate about crushing certainly is still open, and it changes according to the precise deposits. I think that obviously then once you crush the ore, you move a bit into screening, and I think you have some experience in screening in iron ore, Luca. Is that correct?
Absolutely. I think, so as you mentioned, first we'll look at crushing. You mentioned the sizer as a good option, which is something that we provide, particularly to deal with some of those, the clays, the silica, the mud, which might come with the ore body. Then it gets washed in a scrubber, and there's a kind of two combinations that we come across and we provide, which lean into the screening side a little bit. Usually you find that, at least in our, let's say, Western Australian hematite market in particular, the first cut point sits around at that 35 to 40 mil mark, which is what we would provide in a trommel potentially on the back end of a scrubber. And that's an elegant solution for customers that are trying to avoid that first deck of screening in the double deck bananas, which are common thereafter. So that's something that customers sometimes prefer, saves them the story of infrastructure and of construction height. However, we have also done combinations where there is no trommel on the back, and the ore gets washed, moves directly onto a screen thereafter, which then would be a double deck followed by a dewatering screen.
So, Luca, again, perhaps you know a little bit more about this in the screening sense than I do, but you're creating, I think they talk about creating a lump product and a fines product. And, those are kind of two separate markets and often a different grade. And I think at their first screening stage, they're creating, a lump that I think they sell for higher value. So they want to maintain their production of the lump. But then, as you say, that fines portion then can get mixed in with all of the clay and the gangue and silica and all that stuff that they don't want. So you typically would have some sort of fines washing module that might include, cyclones or classifiers or, maybe
spirals
even
as well. Yeah.
Spirals or even heavy media at times. There are some plants running heavy media separation to separate out those products. So the processing plant, starts off as fairly simple, crusher, screen, conveyor. Once you have to get into beneficiation, suddenly the plant is growing and it's getting bigger and bigger and bigger. And typically putting in 20 million ton per annum modules would be a kind of size for an iron ore plant these days.
Absolutely. And we see mine sites with multiple modules, some of them commanding 40, 50, 60 million ton annual throughput. So I guess when we talk about the declining ore quality, the addition of that wet process is probably what comes to mind for us the most, isn't it?
Well, it does, but then of course that leads into the challenge then of having to manage all the tailings. And, I think most wet plants certainly have had a tailings dam. The significance of that is often around, managing that water volume. So whether you have a dry stack deposition or you go as far as filtered tailings, all of those things are contingent really upon the site requirements, the site location, the climatic conditions, the topography, all of that sort of stuff come into play about how you create that tailings storage facility.
And the recycling of water thereafter is also another component. As you mentioned, the process gets a lot more complicated once we add water. Initially, when it was just the dry plants, it's basically a materials handling exercise for the most part, isn't it? So water addition, I'd be keen to get some of your maybe war stories experience in removing some of that water and recycling it and where some of our product lines fit in there.
Yeah, well, almost always the go-to is some form of thickening process. And, historically the iron ore mines of 40 or 50 years ago that had wet processing had very big thickeners. We're talking, 60, 70, 80 metre diameter units that sat on the ground. And, by sitting on the ground, that has lower infrastructure costs, but brings issues around managing the underflow withdrawal. Do you use a tunnel? If you have a tunnel, you have a confined space. If you're in a cyclonic condition, if you've got underground tunnel, is that a health and safety risk? So as the thickening technology has evolved and people have been able to develop high rate thickening to a much greater degree using flocculants, the go-to has been the elevated thickener. The practical limit from a commercial perspective for an elevated thickness is usually around 50 metres in diameter. Once you get over that, the support structure, the infrastructure costs to hold up all that big body of water starts to become prohibitive. And so you might go to multiple units. So you've got some sites that are running, multiple 50 metre diameter units, and others are running, extending into filtering those tailings as well.
Certainly imperative for areas where water is scarce, which is quite often the case, particularly in our environment here. Well,
ironically for Australia, I think in our Pilbara region, certain times of the year, they have no shortage of water. So I think water availability is probably not such an issue. But as you touched on, water accessibility, water rights, how much water can you take? What quality of water do you have to put back into the environment? All of those issues are becoming, paramount in terms of a license to operate.
Absolutely.
Hey, Luca, it's interesting when we talk about iron ore, we tend to think of the dominant industry here in Western Australia, which is hematite processing. A fairly simplistic flow sheet with a couple of stages of crushing and then perhaps, washing to remove the clays, and then maybe a tailings management. But, for other people around the world, magnetite is a much more widespread ore, and even in Australia, there's a lot more magnetite than hematite. But the processing challenges around magnetite. There are magnetite operations in Australia. I think it's the dominant ore type used in China. So feeding their blast furnace technology, that's what they're comfortable with. It's from a mineral processing equipment perspective, it's obviously much more interesting because you're starting off with a 30-40% iron product, and you're having to upgrade that substantially. So they're typically crushing, grinding, floating, separating, on a much bigger scale than the hematite guys. So their costs are much more, but the advantage for them, and we have one local operator here in Western Australia that therefore makes a higher grade iron ore from magnetite. So the magnetite is then marketed as a superior product because it has more iron content in the final product. But to get there, you've had to use a lot more equipment, right?
Absolutely. And I think on the back end of those processes, because we're dealing with a much finer product, removing the water at the end becomes a more substantial challenge, because there are limitations around what you can put on a ship, right? When it comes to iron ore and the level of water that should be in there to let it go.
Yeah, that's exactly right. Obviously, to liberate the magnetite, as I said, you're typically using some sort of grinding mill, and you're grinding it down to sub 100 micron or probably a lot more. So then you're producing a tailings that has a much finer particle size distribution, and a concentrate. And so dewatering those is much more difficult. In the hematite operation, much more common to just use a thickener, gravity separation. But I think for magnetite operations with that finer particle size, typically you'll have to bring a pressure filter into play.
Absolutely, and that adds an extra layer of security, because the last thing you want is your ship's turned up and you can't sell your product, you can't take it overseas. So the implementation of filter presses is becoming more predominant for that market, isn't it?
Yeah, well, that's true of many concentrate industries where you've gone through that fine grinding stage. So copper is the obvious one, but there's zinc and lead and multiple other ones, nickel, where you'll have to dewater your concentrate to be able to ship it. The transportable moisture limit, TML, that's commonly referred to, that's down around less than 8%. And if you've got a really fine growing product, to get down to that moisture level requires a lot of force. So you have to have a high pressure filtration system.
Richard, one thing we've seen in multiple scenarios here in our market is, as you mentioned, initially it was crushing, screening, moving that material and being able to ship it as is. And as the ore bodies progressed, all of a sudden we have the requirement to wash, to remove some of the unwanted material. We've had quite a number of scenarios like that. What would you say to your customer? What are we considering at that point when we're implementing the wet side of the plant?
Most of the time, it's that fine clay that you're wanting to remove, and those clay particles become typically attached to the iron ore, and so you're wanting to just wash that off. And a rotary scrubber or a log washer or other equipment like that is a relatively low cost add-on to the process. You're not providing an awful lot of energy. You're not you're not trying to attrition it. You're not trying to break it down into smaller particles. You're just trying to loosen off all of that loose clay and unwanted stuff. So upgrading that, but as you mentioned, Luca, it's quite common for the producers to stage their expenditure. So they might start off with just a dry crushing screening plant, but then as they move, perhaps below the water table, they move into more difficult ores. Then they will add on the wet plant. And look, as I think we talked about before, we've seen that in several instances where the plan has always been to move into a wet plant. But if you can defer that expenditure, I think any sensible accountant will tell you that's what they want to do.
Absolutely. And there's two things I always think of when we're talking about scrubbing in general, and it's how much water as percent solids you're adding to that material so that the clays that you mentioned can fall apart and separate from your good tucker, so to speak. And then there's the amount of energy and time that you're spending in that scrubber, isn't it? And both need to be considered.
Yeah, that's exactly right. And I think we talked about this before, Luca, but for instance, the residence time that we're seeing, can range from anything from 20 seconds in your scrubber to over 2 minutes. So, often test work can be really important when you're configuring that equipment so that you can make some value judgments about how to size your equipment.
Absolutely, because that size can vary significantly, and your costs can blow out either way based on how that clay is behaving. There are some adjustments that can be made in the field. I think there's some innovations that we've made for that. Richard, is that right?
Yeah, certainly. We often add some form of adjustable end weir so that we can change the volume in the scrubber, so you can change your residence time. You can clearly change the lifter and liner profile to increase the energy uptake if need be. You can change the speed. So all of those things you can change to a degree. But if you're designing for 20 seconds residence time and you need 2 minutes, you're probably not going to get there with your infield changes. So it's something that we do a lot of, Luca. I think you've been involved with that. Is getting involved with the test work at an early stage. To understand the customer's challenges, understand their ore body as best they can, and to make value judgments about equipment selection.
Absolutely, and as part of that testing process, you want, if it's possible, to potentially test a number of different ore bodies because they can vary significantly. At least that way, it narrows the band of the requirement of that residence time, and then the weir adjustment mechanism, we can kind of narrow it down to a certain band that those multiple ore bodies would fit under.
Yeah. Look, we always talk about that, don't we? That the testing is only as good as the sampling. So if you've got a representative sample to test, you're going to get a much better outcome. But how do you define that when perhaps you're considering an ore body that's hundreds of millions of tons, and you've selected a 20 kilo sample to test? That's again a challenge for the geologists, I suppose, not really the mineral processors.
And I guess we get so focused on the washing side of it in particular, removing the clays, but we sometimes underestimate how much that helps the process downstream. If you've got high clay product falling onto a screen straight afterwards, that's a mess. It can be a real problem afterwards, and adding that amount of water to remove it is far more difficult later down the flow, isn't it?
Yeah, I think we've got a whole separate presentation on managing mineral processing equipment with high clay content. It just makes everything more difficult. It kind of clogs up everything, and takes more energy. And the sooner you can get that out of your process and deal with it separately, the better product you'll get, and the easier processing, the more throughput, all of that good stuff like that. Look, we touched on testing, and as a supplier of equipment, we really value that, to be able to configure the equipment, for the best outcome for the customer. So our specialty is particularly in crushing of ores, and then washing of those and managing the tailings. So all of those processes require, would benefit from test work. So that's a part of the service that we offer, because it certainly helps us when we come to installing the equipment.
Definitely. Richard, we've got quite a topical time in iron ore. We've got the introduction of some new international players in the market, which do have a direct and indirect effect on our market here. Probably the big one being discussed at the moment is Simandou out of Africa, which, from what I understand, is commanding quite a high ore percentage straight out of the ground. And I guess, how does that affect our market? What do you see there?
Look, as I mentioned before, Luca, iron ore is an internationally traded commodity, and the buyers will canvass the world for the cheapest and most reliable sources. The big question mark really is Guinea, and the deposits there apparently are very productive, but the infrastructure is a problem. The a political situation is probably not as stable as some of the other Western countries. And so there's varying opinions as to whether that will be the Pilbara killer, as the press talk about, or whether they'll just struggle to get off the ground. That obviously will challenge the existing producers to define their supply chain as being more effective, more consistent, more reliable. And that probably then in terms of influence for us pairs back into having reliable equipment operating. So it will have influence on what we do and how we do it, but who knows? Time will tell.
Absolutely, it's the old story of the established player, which in this case is Western Australia and Australia, already having quite low running costs, as you mentioned. Requiring reliable equipment and to ongoing using the existing infrastructure, the rail, versus a completely new but very high grade, desirable product. When we talk about equipment and its reliability, what comes to mind, and how do we sort of approach our customers to ensure that keeps running?
Well, that's an interesting point. What an important aspect that we offer as an OEM is support and service, and making sure that the availability is really good. If you're having to operate in remote areas, Africa is the topical one. How good is the local infrastructure, and not just equipment, but the rail, the trucking, the roads, the airports, all of that sort of stuff. How reliable is that to maintain good availability? Iron ore's, I said a commodity. It's a semi-commodity, but selling at $100 a ton, you've got to be putting through a lot of tons on a regular basis to be profitable. So availability is an important issue for all of these. That probably leads me into a discussion about supply chain. I think probably 4 or 5 years ago, the price and delivery of equipment seemed to be the overriding issue. But I think all of the owners and operators have realised that it's not just about getting efficient supply, but having a reliable supply. And so the whole international supply chain issue is becoming a much bigger question.
Absolutely, and supply of this equipment. I think one thing that when I think of iron ore is scale and size. The equipment's big. It needs to be heavy duty. It's heavy. The road limits are always exceeded. There's all those sort of logistical problems that come along with that. And as a result, as you said, that it's something that needs to be deciphered as part of that supply chain. So established suppliers that have the ability to get on the ground and deliver that equipment, install it on site. There's huge crane lifts and other risks associated with it that come into play as well.
Look, you're absolutely right, Luca. The experience that comes with having done it before is a bit hard to trump often.
Richard, you mentioned high throughputs, and consistency becomes imperative there as well. To get the tons on the train, get them off the port for suppliers to remain profitable. That means that equipment needs to stay online for many weeks at a time, I think 12, 13, 14 weeks. And the way that we operate after that is we shut down. Generally, our clients will shut down, and then all the maintenance needs to be done at once. This is quite unique to the iron ore industry in a way, isn't it?
That's exactly what I was going to say, Luca. I mean, other mineral processing, be it gold or nickel or mineral sands or anything like that, they might run an annual shutdown, and they'll shut down for 2 weeks annually, and they'll go through and check the maintenance, upgrade the equipment, do what they need to do. The kind of unique aspect about the iron ore producers is they'll tend to run on a much shorter schedule. So that might be 13 weeks, it might be 20 weeks, it might be 24 weeks. But either way, it's shorter, and that's obviously a function of the fact you're whacking through so many millions of tons, and you've got abrasive, heavy ore. So managing the wear on the equipment is probably paramount for these guys, and much more important than you might see perhaps in a coal plant, where they'll, in a similar basis, they might be putting through millions and millions of tons, but the ore is not as abrasive, it's not as hard, it's not as heavy. So, specific for iron ore is these sort of much more regular maintenance campaigns. And, from our perspective, that, leads into the expectation that they'll be getting service from their vendors to help maintain the equipment uptime, to ensure the availability is there, as we talked about. So I think that's kind of unique for iron ore.
Absolutely, and I think certainly in our market, there's an expectation that you have a partnership with that producer. As a supplier, you're involved with maintaining the equipment, making recommendations, perhaps adjusting it according to certainly wear patterns and products. That's probably somewhere where we've spent a lot of time in a number of our products, spent optimizing wear and duration, because certainly our customers are always asking for longer times between shuts. They're being subjected to serious wear and problems that are associated with that, aren't they, Richard?
Yeah, look, absolutely, Luca. So matching the wear life of those wear components with their shutdown schedule becomes a kind of iterative, opportunity to synchronize. So in some cases, you're right, it may be extending that wear life for much longer time, or perhaps in some cases it might even be actually pulling that back a bit, so that you're not replacing equipment that is not worn out, but it won't make it through till the next shut. So it's you're right, for an equipment vendor, understanding the obligations and implications of each site is an ongoing task for us, and an important task.
Absolutely. And I see it as managing it sort of two ways. One way, it's the relationship with the customer and the understanding of what the equipment's doing. So we can then feed that back the other way, and dealing with our supply chains, and then finding the best materials which will help us achieve those requirements of our customers. Implementing new materials that will optimize wear. Perhaps they might need better screening or throughput, open areas. So there's always ways that we're looking to optimize, and you can't have that unless you're close to the customer and you're there at those shuts. You're understanding their problems, and that again, I guess, leads and loops back into the established players and the established suppliers which are within those markets.
And overlying all of that is the fact we're dealing with variable ore quality. I guess that's one of the challenges of mining, is that your ore quality varies over time. It might be the hardness, the mineralogy, the makeup, and the challenges obviously for the miners particularly is to try and even out that variability. But despite their best efforts, and I'm not a mining engineer, so I don't quite understand all of the intricacies that go into that process. But despite their best efforts for the guy in the mineral processing plant, they still have to manage that variability, and that might be on a short-term basis, or it might be over a long period of time.
Absolutely, and I think another one is a variation in clay. Particularly as the ore qualities decrease, you've got more of the stuff we mentioned earlier, silica, gang material, as I think it's referred to quite often. What are some recommendations? I mean, we're talking quite a lot in the front end, sort of crushing and washing. What can be altered from our perspective in those situations?
Well, look, certainly in the crusher, there's obviously adjustability that you can make to the gap of the crusher, or the speed of the rotation of the rolls, or other issues like that. For the scrubber, you can change the density of the feed. You can change again the rotational speed. You can change the weir height that changes the residence time. And what I guess I'm intrigued about, Luca, is the fact that all of the operations are looking more for more automation, trying to integrate AI tools to be able to make these adjustments self perpetuating or self creating. And I think that for us as vendors, there's a increasing expectation to supply that form of bundled automation that enables the operators to pick up on the variability and manage that variability.
Absolutely. I think everyone wants to be preemptive instead of reactive, minimize downtime again.
Luca, one of the other things that I guess we hear a lot about in the industry is, mine of the future is one of the majors say. And, their mine of the future implies a lot more automation, a lot less people on site. A lot of the major operations are running remote operation centers from thousands of kilometers away, or miles if you're listening to this in the US. But what that means for us as equipment suppliers is increasing the level of automation and remote monitoring that's required. And there's an interesting discussion around that, because there then becomes a challenge around intellectual property. Who owns that data? As an equipment operator, we're interested in how the equipment's operating. We want to optimize it. We want to use it. But sometimes some of the customers consider that information and they're reluctant to share it. So I think that's a kind of emerging trend or question as to who owns that information.
Absolutely, because as the suppliers, obviously we want the information because it's valuable to us optimizing it for that customer. Whilst at the same time, it is their ore body, and how it operates is their information. So it's a conversation, as you mentioned. It's arising more and more.
So then it's sometimes not about the technology that's available, but it's about the question of who owns the information and who uses that information. And I think that it's interesting that obviously we're familiar and interested in mechanical equipment, and we know how to design that and how to operate that. But then you get into this sort of kind of difficult to define IP issue about information. I mean, it's not unique to our industry. I think it's a worldwide trend about who owns information and how that information is managed and used. But obviously that's then those questions or discussions are transitioning through right into our industry.
Definitely. Appreciate it, Richard. I've always learned more when I talk to you. Highlighted a few things that I need to go back and do some more homework on, so thanks for your time. So thank you for listening to Groundwork, a McClanahan podcast. Be sure to subscribe on your favorite listening app for new episodes, and follow McClanahan on social media for more.
Hi, I'm David Hunter, Business Line Director for McClanahan. If you like this episode of Groundwork, be sure to watch these other episodes. Like, subscribe, and hit that notification bell to stay up to date on new episodes. Thank you.